Hello, everyone. Hello, Mr. Deblis. Hello, Abed.
Hey, hello, how are you?
I'm fine. What about you?
Good.
How was the week?
Nice.
Okay.
So I tried the placement data you last
Mm-hmm.
time you gave us, and can I share with you for just 2 minutes, or you wanna move forward?
You can share this.
Just to show you
Yeah,
how.
yeah, sure. Just show me. And this is again a very, very, the appreciated that you have done with this.
Yeah, I think it's I exactly follow the
Yeah.
instruction you provided, and then uh, this one. Can you see now the shared screen?
Yes, yes, yes.
Okay, so that's I tried both without normalization and with normalization.
Okay.
So there is no big difference. I think the accuracy rate is 54 with normalization and 53 without normalization. So this is the one I shared is without
Okay.
normalization here.
Okay.
And I follow all the steps and thank you so much. I think it looks good. So can you see here now 54%? I
Yes,
think
yes,
50%. So,
yes, yes, yes. Perfect.
and yeah, so without normalization, it's with normalization, it's 53. I think so the accuracy score is very low.
Yeah, the accuracy is right now the very, very less accuracy we got it. Okay. Then without, no, with normalization.
Windows, okay, so let me go ahead and share. I think I with normalization. Uh, okay, so can you see now the share screen? Can you see now?
Yes.
Okay, so everything looks fine. I think this is with normalization. I did all the way down, and
Mm-hmm.
I got 53%. But I tried to display classification reports when I look into some document.
Okay.
I try to display the coefficient and the p-value
Okay.
and so it didn't give me the results. I stopped it here. Otherwise, I think the percentage 53%. So I got 53% accuracy rate with normalization and 54% without normalization. And other than this, I
So
think the
so so what's the accuracy with normalization?
54.
With normalization.
Yes, 54.
Hmm.
Oh, with normalization is 53, I think. 53, sorry.
53.
Yeah, that one is 54.
Okay. 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 So there are actually, I think the problem is with the data, I think. So that's why it is not.
Yeah, yeah, I think absolutely. I think that the most important thing is for me to learn the procedure, how to perform
Okay.
logistic regression.
But
And I exactly.
so
Mhm.
show me your input and output data set.
My output data is placed one,
Okay.
which is
Okay.
binary, placed or not placed,
Okay.
and CGPA and placement exam marks are outputs. No, no, inputs. Those are inputs. CGPA
These
and
are
placement
inputs. Yeah.
exam marks
CGPA
are
and
inputs.
placements are the inputs.
And the placed is output, which is a binary, 1 and 0.
Mm-hmm.
So was that okay?
Yeah, okay. So, okay, this is absolutely fine, and this is completely fine because you already uh, you are already done with this, and you are practicing all these questions on that particular data set. And in the future classes, we will do a very good projects and very good models that will give you the
Mhm.
very best accuracy. Okay, and we
I
can
think
say
it's
that
okay.
yeah,
Honestly, I didn't focus on the difference between accuracy percent. I think for me, the most important thing is to be
yes,
able
yes, to
to
understand how to
follow
code
your
this.
step and be able to complete the logistic
Exactly.
regression and
This
the
is more
data.
important. This is more important than the evolution.
That's
Right.
right. That's right. Exactly.
Perfect.
Thank you so much.
Perfect. Perfect. Fantastic.
All right. Bye.
Okay. What about you, Sam?
I had trouble doing it.
Okay. Just keep practice on this. Okay. Okay. So let's start the session today. Uh, basically, today we are going to start a new project which is based on the algorithm that is KNN, K nearest neighbor. Okay. Okay. Let me share the screen. Can you see the black screen right now? Okay. So just recap the previous class. So we have done with the logistic regression. Okay. Recap. Okay. So we have done with the logistic regression. And today we are going to start KNN. And that is what? K nearest neighbor. KNN stands for K nearest neighbor. Okay. So when it comes to KNN, if I say in a single line, KNN is very simple, very dynamic, and very very elegant. Okay. So if I write about this, first of all, it's a supervised machine learning algorithm, and used to solve both the classification and the regression type of problem. Used to solve the both regression and classification type of problem. Okay, so two things about the KNN. Now, what exactly the KNN work on? So
Can you scroll up a
KNN
little bit,
predicts the
sir?
category. Yes. Is it fine?
You can scroll a little bit down. I just need the supervised part. Yeah. No, it's fine.
Okay.
You can scroll down.
Okay, okay.
No, before.
So
Before
KNN
how?
predicts the category. Sorry, come again.
Can you scroll back up? I'm sorry.
Is it fine? Don't worry, don't no need to write right now. At the end of the class, I will share the notes. Okay, so don't worry. Just try to focus on what exactly this is. Okay, what I'm teaching right now. Just focus on that. I will give you proper time to this. Okay.
Okay.
Yes, Sam.
Okay.
Okay. So KNN predicts the category of new data by looking at the categories. By looking at the categories of its k value. K value means closest neighbors. Closest neighbors and and picking one that appears the most. Appears the most. See how the prediction is calculating or how the prediction is happening. So basically, when we talk about classification, we are talking about classification. And we are talking about binary classification. Okay. So in binary classification, basically two possibilities are there, whether the thing is yes or no. Okay. So I'm plotting one diagram here. Basically, we have a two class. Okay, just do one thing. So we have two classes here. The first class, these are the data points of the first class. Class means the variables or the column, you can say. And we have another class, and these are the data points of the second class. Okay, so this is what this is class 1 and this is class 2. Okay, not again why it is happening. Just hold on. Okay, class 2. So when it comes to prediction, okay, when it comes to classification prediction, when the new data comes into the picture, okay, a new data point, if we have a new data point, okay, let's say this is your new data point. This is your new data point. Okay, so basically there is a process how to calculate it and how to predict this. Okay, this one is new data point. That means you are this is your new input point, and that you are looking for the output. Okay, so when the new data points comes into the picture, then how the KNN works on. So basically we have a process. Okay, so we have a process what? And we need to find whether this new data point belongs to the class 2 or class 1. Okay, so basically we have a process how it works basically. So first of all, it calculate the distance between the two or the nearest data point. The first thing, distance calculation. Distance calculation. Distance calculation. So basically to find or to calculate the distance that the point which is nearest to the mostly occurs, let's say this one is your data point, new data point, and this data point will find the nearest data point. See, this is the nearest data point. Okay, and this one is nearest data point. Then how many nearest data points we have? Two nearest data point. For class 1 we have two nearest data point, but when it's compared with the second class, class 1 and class 2, okay, let's say this one is nearest data point, this one is nearest data point, this one is nearest data point. I'm sorry for this. Let's say this one is your nearest data point to the new data point, and this is your nearest data point, and this is your nearest data point. Now tell me how many nearest data point we have in the second class? 3, right? 3. So it will count the majority point, okay, which has the maximum number of data points, which has the maximum number of nearest data points. So in which class you have the maximum number of data points? Class 1 or class 2? Tell me.
Looks class 2.
Yeah, exactly. Class 2. So basically, it will say, the new data point will say, or the prediction will say, that your prediction is going for second class.
What the
Why?
class 2
Because it
has?
has the number of, see, let's say you are predicting whether the patient is diabetic or not. Okay, so class 1 represents no. Okay, and class 2 represents yes. And number of answer is getting 3 with class 2. That means the prediction is belongs to class 2. That means the person is a diabetic. Why? Because we have a 3 nearest data point with the new data point. Clear? Is it clear? This is very simple. If you are going to predict whether the input is belongs to class 1 or class 2, class 1 or means class 2 means the no or the yes. So let's say when we calculate the nearest data point to the new data point, then it will say, yeah, two nearest data point we have with the class 1, and 3 nearest data point we have in the class 2. So the majority counts will say that your prediction is going to be for class 2. Why? Because we have a maximum number of nearest data point in that. Is that clear?
So that's for classification, right?
Yeah, this is for classification. Okay.
So what about for regression? How do we?
Yes, I will come to that point. First you understand this. Okay.
Okay.
So basically, what's the whole process of that? Okay.
Okay.
So distance calculation. So to find or calculate the distance calculate the distance that the point which is nearest to the mostly occurs. Nearest the to the mostly occurs. So basically we have a Euclidean distance formula, right? So for this we use Euclidean distance formula to find the actual distance between two data points. Okay. And actually it also measures the straight line and the distance between two data points. Okay, so I'm just writing here which actually measures the straight line distance between 2 points. Okay, so let's say for two coordinates, if we have a two coordinates, for example, so the distance is dA is equals to root x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so if we have two classes here, like we have a two data point, that A and the B. Okay, these are the data points and we need to calculate the distance between A and B. Okay, and the coordinates is x1 y1 and x2 y2, right? So for this will be your formula to calculate the distance, right? Now again, if you have a 3D coordinates, if you have a multiple classes.
I'm sorry, what's the name of this formula?
Yes, Zelda.
What's the name of this formula?
Euclidean distance. Euclidean distance formula. See, I've written
Okay,
here.
so sorry, I couldn't read that.
Okay.
How do you spell that?
Euclidean distance formula. Euclidean. Okay, so I'm just writing the spelling once again. Euclidean. Euclidean. Okay.
Yes. Okay. Thank you.
Okay. So this is for 2D coordinates, for 2D, for two dimensional. Why? Because you have a two columns. But when it comes to multi classes, or you have a 3D coordinates, for 3D coordinates, so basically we called it hyperplane. Okay, don't worry what exactly the hyperplane is. We will discuss in the future classes when we start SVM, support vector machine. Okay, hyperplane. Now what is that? Let's say if you have 3D coordinates, then your diagram will be like this. Okay, and let's say you have a two data points. Okay, this one and this one. So this is A and this is B. Okay, so this is your X, this is your Y, and this is your Z. So now to calculate the distance between the two data points from A to B, okay, from A to B, your coordinates will be x1, y1, z1, and x2, y2, and z2. Okay, so you will be doing the calculation like this. Okay, if you have a 2D. So basically, most probably you are using Euclidean distance for 2D coordinates. Why? Because when it comes to a classification type of problem, you will be using 2D coordinates. Why? Because it only have the two possibilities, whether the thing is right or whether the thing is wrong. Now, how it works. So once it calculates the distance between two data points, then it will try to find the closest neighbors to a new point. Okay, just write it. So KNN tries to find the closest neighbor closest neighbor today. This is neighbor to R. Not again. Just hold on, guys. I just want to close it and just reopen this. Okay, so KNN tries to find the closest neighbor to a new point. It calculates the new point and every point in the training data set. In the training data set. data set. Why? Because it only happens when we train the data. Okay, it will do all the process internally. Now, once we calculate the nearest data point, then after the second number of thing is sorting and selecting k nearest neighbor. Okay, sorting and selecting k sorry k nearest neighbor. So basically, after the collection or after calculating all the data points value, KNN sorts all the points by distance from the new data point. Okay, so let's say this is your new data point, and it actually find there are two data points we have from class 1 and three data points we have from class 2. Okay, then it will find the distance. Okay, then it will calculate the distance. Then after the calculation of distance, it will sort all the points. Sort all the points means how many data points we have in the class 1 and how many data points we have in the class 2. Okay, then it will count the majority, the third number of voting, or we can say majority count. So with respect to new data point, with respect to new data point, it will assign the category assign the category means the class. Okay, that have the highest majority. Okay, so let's say class 1 has 3 and class 2 has 2. So it will recommend class 1. Now, this is the process basically for the KNN, how it basically works. But when it comes to regression type of problem, okay, so Mr. Dimles has asked recently, when it comes to regression type of problem, so the output is in the continuous form, right? Now regression. So basically your output would be in continuous data. like continuous data, like uh 5, 6, 7, 8, 10, whatever you have. Okay, let's say you are predicting the price of the car. Okay, so every car has a distinct price, right? Every car has a unique price. So this is the problem of regression. Now output will be in the continuous data. Now, so what happened? Let's say this is your data. And see one more thing about this. K stands for K nearest neighbor. Okay, and you have to take a value of K. You have to take a value of K, right? And the optimal value, basically we take the optimal value, and the standard value are K is equals to 5 or 7. And always remember one thing, we need to take a odd number. Why? Because then we will find which exactly the maximum number, right? So if we take 4 here, and what are the chances that we are getting 2 for one class and 2 for two class? It will happen, it may happen. But so for this get afraid, we are taking odd number. So when it comes to 5, 2 and 3 will happen, and when it comes to 7, 3 and 4 will happen. Okay, class 1 for 3 and class 2 for 4. So in this way we can easily define which category that data belongs to. Clear with the value of K, Nemles?
In the regression, can you repeat again? I didn't
Please.
understand it.
No, that's for that's for classification. Let me show you one thing. Just delete from here. We will take the K value for classification. Okay, 5 and 7, and for regression also. Okay, just let me write here. Standard value of K is 5 or 7. 5 or 7. Why? Because we need to take a odd number. So that's why we will define whether the class 1 has 2 or 3, whether the class has 3 or 4, same as the regression. So when it comes to a continuous number of data point, let's say we have a new data points comes in the picture. Okay, and we need to predict. So let's say my K value is 5. Okay, my K value is 5. So it will calculate 5 nearest data points, right? So let's say this is your nearest data point, this is your nearest data point, this is your nearest data point. It will take 5 data points, nearest data points. Okay, so what would be the prediction? Y pred is equals to, for regression, so d1, then add d2, then add d3, then add d4, and then add d5. If we are taking 5, the value of K is 5. Okay, and just add the number of data points. So we are taking the average value of the closest nearest data point. Okay, it is just for the regression type of problem. Why? Because we have a continuous data. So if we get the value of d1 is 2, if we get the value of d2 is 3, 4, 5, and 6. Okay, how many number of data points we have? 5. So 6, 4, 10, 5, 15, and 5, 20. And when we divide by 5, we will get 4. So now your prediction is y pred is equals to 4. This is for regression and this is for classification. The majority count will goes for classification and the average process goes for regression. Clear, Devlesh?
Yeah, yeah, makes sense, yeah.
Yeah, perfect. Now, if it is done, then just go for a hands-on. Okay. So I am sharing one data set with you guys. Just open your Google Colab. Yes, be ready for this. Just create a new file, more Google Colab. Okay, just connect this file and just rename this file KNN algorithm.
KNN algorithm. Algorithm. KNN. What is the KNN means?
KNN stands for K nearest neighbor. See, I have
K
already
nearest
mentioned
neighbor.
here.
Oh, I wasn't here at the
K
beginning.
nearest. Okay. K nearest
Okay.
means you are finding
K
the
nearest neighborhood. Okay.
nearest data points. Okay.
Nearest data point. Okay.
Okay. So today we are going to take a different type of data set. Basically, we are predicting whether the person has a breast cancer or not. Okay. So we are using breast cancer data set. Okay.
I couldn't get the message.
Breast cancer detection.
Sir, I couldn't get the data set.
Yes, just hold on. I'm sharing. Breast cancer detection with KNN, because this is a classification type of problem. Okay. Okay, so I'm just sharing the data file to you guys. And you can also check for what this type of data on Kaggle also. Okay, you will be able to find this data set in the Kaggle platform. But okay, I'm just sharing here. Just take the file and just load it to your machine and just get ready for the process or the cleaning part we have. Okay, so just load the data set. Just copy the path. Just close this and just write load the data set. First of all, import pandas as pd, import numpy as np. Load the data set. So df is equals to pd dot read underscore csv. Put the parenthesis inside the quotation. Just paste the file. And now just run this. So df dot head. Okay, so total we have 33 columns. Total 33 columns we have. So we have a ID of a patient, okay, and we have a diagnosis, MM, and I think there is also M stand for meningitis, I mean benign, and B stand for benign. Okay, we will check into that. What exactly this? Okay. And we have a radius mean, and we have a texture mean, parameter mean, area mean, smoothness mean, compactness. So basically these are the columns which is nothing but they are the input columns. Okay, input columns. Let's see. Because we have a 33 columns here, so it is not possible to show at this time. So we can go with the columns. So we will write just show the columns. So all the columns. So df dot columns. When you write this and when you execute this, you will get all the list of the columns. See, so we have columns ID, diagnosis, radius mean, texture mean, parameter. Okay, so these are the columns we have in this data. Now unnamed 32. Let's see unnamed 32. What exactly inside this? If we go at the last end and we check what exactly we have in this. So nan means there are missing values in this data. Okay, so tell me guys, what's your opinion? What I do for this? Should I remove this?
Yes.
Should I remove the unnamed 32 column?
Yeah, the missing value we can remove the
Yes.
practical.
Yeah, because there is no any information in this particular column.
Yes, so no needed. Yeah.
No needed. Okay, and same thing. We also don't want ID column. Why? Because this only gives you the information about the patient, not gives the information about the biological information. We don't have biological information in ID column. Okay, already when we are doing a prediction or when we are predicting the regression or the classification type of problem, we only want the biological information, not the statistical information.
It's,
Right or not?
yeah.
Okay. So in this way, we can remove ID column and the last one, which is unnamed 32, which is not required anymore. Why? Because it doesn't gives me any important information about the patient. Okay, with the help of ID, you can just check which person is that, which patient is that. But when it comes to prediction, it doesn't require anymore, right? Now, just do one thing. Just check for diagnosis, which is our output column, which is your target column basically. Okay, how many categories we have? Why? Because this is your classification type of problem. So it may be there are two possible categories, right? Let me check it. df dot value counts, value underscore counts, and put the parenthesis and just write the name of the column. So just copy from here, Control C and Control V, and just run it. Okay, see. So we have 357 in B and 212 in M. Okay, so basically B stand for benign and M stand for malignant. Okay, let me show you. Who is the medical student here who have a knowledge of benign and malignant?
Not sure.
Okay.
Knowledge of what?
I work
Okay,
pharmacy,
so
but I never heard this word.
I think benign is the one that doesn't
Oh,
disseminate, and
benign and malignant.
yeah, benign and
malignant
malignant.
means
Yeah, yeah.
Okay.
it
Oh,
distributes
yeah.
throughout the body.
Benign
Benign
is non-cancerous
and
and malignant can turn into cancer.
Mhm.
It
yes,
can
yes, yes.
spread.
Okay. So basically, when it comes to benign, that the person is getting cancerous, right?
That's malignant.
That's malignant. Okay. So when it comes to malignant, that the person is a cancerous patient, right? And
Mhm.
when it comes to
Right.
benign, that means the person is not the cancerous person. Okay.
Right.
Uh, Actually, we can say that when it comes to malignant, there are so many numbers of, or I mean, the unwanted number of cells we have, right?
Mhm.
Okay, the maximum number of cell. And when it comes to benign, that means very less number of cancerous cell. So
Cancer
that's
cells. That's right. Right.
why it is not opening.
So benign has the cancer, right?
Okay.
Can you hear me?
No, opposite.
Yeah,
Oh,
see,
opposite. The malignant
Mhm.
has cancer?
Mhm.
Right.
Okay.
benign tumors are non-cancerous while malignant tumors are cancerous. Yeah, this is okay. So just do one thing. Just copy this and just paste here. So you guys will get about this. Okay. So benign tumors are non-cancerous while tumors are cancerous. Okay, usually don't spread while malign tumors can spread to other parts of the body. Yeah.
Excuse me,
Yes.
sir. Can you show me what you just typed before? I don't think I typed it right.
Where?
No, the last code.
The last code. This one?
No, the code before the message.
This one?
No, not columns. The one after that.
I think this is the same as the previous we have done. load the data set. Just define the variable and just with the help of pandas, just read pd.read underscore csv.
No, like the one after the columns. The one after columns.
After columns, the value counts.
Yeah, value counts.
Okay. I think this also we have done in the so many times in the previous classes. Okay.
I just wanted to. Okay,
Can
thank you. Thank you, sir.
okay, okay. So what we are doing here, basically just drop the unwanted column. Drop the unwanted columns where ID and unwanted or unnamed 32, which is the last column, are not required anymore. Sorry. So tell me guys, how will you do this? How can you drop the unwanted column? The ID one and the unnamed 32. The first one and the last one.
So delete one.
Can you do df.drop
Yes, df.drop.
columns and then you name the column?
Just try in your machine and just show me.
Which columns are we dropping? Which one?
The ID column and the unnamed 32, which is the last column.
Oh, I see. Okay, okay.
This is the first column that you want to remove, and this one is the last column. Okay, so we will have once we delete this column, we have a proper data set. Okay. Done. Done, everyone? I'm just waiting for you. This is very simple.
It's
You have
it
to
gave
write
me an error.
line column. Yeah.
So I
Yes, Mr. Douglas.
it gave me an error. So df dot drop
Okay.
and
Columns
just
is
brought
equals
it.
to.
Yes, and then column ID and then comma
Okay.
and column unnamed semicolon 32.
Actually, do one thing. Instead of writing, just copy the column name and just paste here. Why? Because we have a spaces also here. So sometimes you forget to write or forget to put a space in between the column.
Okay.
Okay. What about Salda? Nazneen? Done with this?
I was having issues as well. Like, I was having errors as well. So I tried to do delete. So DEL, DF, and then I put the name of the columns
DELT?
that way. DEL doesn't delete.
Okay, so why you are deleting that column? No, no, no.
Are we not
No need
deleting
to.
it?
No need to delete. We have a drop function.
It says
Yeah, I was
ID
having trouble with that.
Okay.
and
See.
ID and unnamed 32 not found in the
Uh,
abscess.
okay. So just hold on. I'm just writing the code. Please match with my code. Okay. So my data frame name is df. So df dot drop, and inside drop, I'm using value minus columns. Columns is equals to, you have to put a list of the columns that you want to drop it. Okay. Inside, so inside this, I will just write the name of the first column, that is what? ID. And then after, separate by the comma, and just put a second column name. Okay. Which is what? So instead of writing, as I told you, just copy it.
Okay, so I failed to add columns. So once I added column,
Yes.
it's okay
Okay.
now.
And just do one thing, and just make it permanent. Okay, permanent change. So for permanent change, you will use in place is equals to true. In place is equals to true. Okay, and just run this. Now just check df dot shape. So initially we have 33 columns. Now only we have 31 columns. Okay, so just check it. Df dot columns columns, and just run it and see. Initially we have a first column, that is what? ID column. But now this time we have a first column, that is what? Diagnosis, which is our targeted column. And the last one, the last unnamed name as also unnamed 32. Okay, that is also removed. Clear?
That's right. So this is these two columns are permanently deleted from the DF data set.
Permanently. Yeah, this is permanently deleted. Right.
Okay. Awesome. Thank you.
Perfect. Now just do one thing. Just check for the any duplicated value or any null value. So just check df check for the null values or missing data, if any. So df dot is null, put the parenthesis, just apply the sum function here and just run it. So actually we don't have any null values or missing values in all the columns. See, all the columns we got 0 0 0 0, right? Now your data is cleaned and ready to work for the prediction. So now just tell me, what is the procedure? The procedure is, first you split the data set, split the data into input and output column. Okay, and tell me what is your output column here?
Diagnosis, like
Yeah, diagnosis.
malignance and benign.
Yes, the diagnosis one, right? And the second process, once you split the data into X and Y, then after you will apply train test discipline, right? So then after split the data for training and testing with train test split. Okay. So we are taking just a very quick short break here. And my question is, just please do this. Just please do these two steps. Okay. In between 10 minutes of break.
So
So
what about normalization? We don't have to do normalization
before we
for
go
this data.
on break, can you share the hands-on file link?
Sorry.
Before we go on the break, can you share the link for hands-on?
Yes. I will provide.
Then I can write it down.
See, Mr. Demlis, we will apply the normalization after the splitting.
Okay, got it. Thank you.
Okay. Okay, so just try to follow or just try to do this two stop, basically input and output, then after training and testing. Okay, I think you can guys do this because this is very simple. Okay, if it is not done, then we will definitely continue this after the very short break here. Okay, so I'm just sharing the file. Okay, so just see in the chat box. Okay, got it, Sajib?
Yeah, I'm opening
Okay, perfect.
opening file.
Okay, done everyone? The two process, the first one and the second one. Tell me guys. Are you there?
Yes.
Oh,
Yes, we tried. I tried.
okay. So done with this? Okay. So I am doing the process. Okay. Input data. So when I try to split into x, so I will define x is equals to, if I drop the column, if I drop the first column, that is what? Diagnosis. So the remaining will automatically comes inside the what? Input columns. Okay. So df dot drop and columns columns is equals to, make a list of this. So I just want to drop only the diagnosis. So diagnosis. If the spelling is not correct, you will get error here. So just check it once again. Okay, so just copy this. Instead of writing, just copy this. And just paste here. Okay. Now x dot head. See, now we don't have any diagnosis column here. See, the first column is your radius mean, texture mean. We have all the input column, right, in x variable. Now what about the output column? See, initially we have 33 columns, then we have removed 2 columns. Then now recently I have removed 1 column, so that's why it is showing 5 rows and 30 columns, right? Now what about the output column? Output data. The output data is your y is equals to, from df I want diagnosis. Just hit enter and y dot head. See, we got only 1 column here in y variable. Okay. Now what is the next step here? Training and testing, right? Split the data into training and testing. So first of all, just import train test split. So from okay, so from sklearn dot, from where? Model selection, right? Model selection. Just import train underscore test underscore split. Okay, just execute the code and then define the variables. Define the training and testing variables. Okay, so x train x underscore train, comma, x underscore test, comma, y underscore train, comma, y underscore test is equals to, just apply the train test split, train underscore test. Okay, you can do one thing. Instead of writing this, just import train test split as as a split. Okay, and just run once again. And now you can use, instead of train test split, you can use split. Okay, just like pandas as PD, numpy as NP, you are using NP and PD, right? So split what? X means your input data and the output data, right? And train size, just mention the train size here. Train size is equals to 80%, so 0.8 here. Okay, and then random underscore state is equals to 42. Okay, now just run this. Check the shape of the splitted data set. Check the shape of the splitted data set. So just print x underscore train dot shape and just print x underscore test dot shape. See, so 80% of your training data set is 555 and the testing part is 114. Same for the y, means your output data. So y underscore train dot shape print y underscore test dot shape. Just run
So
this.
which one is for the train and which one is the testing?
Which one is for the train and which one is for the testing?
The first
train
one is the testing train.
Yes.
Oh,
X
the second one is testing.
X train is your 80% of your input data and X test is your 20% of your input data.
Okay.
Okay, and again Y train is your 80% of the output data and Y test is your 20% of the input data.
Input data. Okay.
Not
The first one is for the X train, which
Yeah.
is 80%.
See, remember one thing, X is your input and Y is your output.
Output. Okay.
Okay. Now, this is the time to apply the standard scaler, means to transform your data. Okay. Text transform or normalize your data. Normalize your data with standard scalar. Okay. Just run this. So from sklearn dot pre-processing import standard scalar. Just run this. Now make an object for the standard scalar. So what I will write here, SC stands for standard scalar. Okay, so SC is equals to standard scalar. Put the parenthesis here. don't forget to put the parenthesis here. Okay, otherwise your code will never be executed. Okay, just run this. Now what you are doing, you are transforming your data. Okay, transforming your training data. Okay, and the standard scalar or the normalization process will be executed for training data set. It is applicable for only training data set. Why? Because we have a multiple dimensions in the input data columns, right? So that's why we are applying standard scalar here, right, guys? Tell me why we are using a standard scalar for input columns, because we have a multiple columns and we need to scale all the values of the we need to scale all the different values of the different columns in a single parameter from 0 to 1. If you guys remember, we have already discussed on that, right? Say yes or no.
I think that's correct. That's right.
Yeah. So
So
x underscore, yes,
we do transform standardization only for
input.
the input one,
No,
the
not for,
training part, right? Not the test part.
yeah, not for the y column. Okay, not for the y data. Y stand for output, right?
Yeah.
We only
Okay.
done for we only done for x train and x test.
Okay.
Okay, so I'm going to make a change on x train. So sc dot fit and transform. We have a fit function and a transform function together. Transform x train here, x underscore train. Now again for x test, x underscore test, because we have a multiple columns in the x train also and for the x test also. So that's why we are going to apply sc dot transform and just put the x test here and just run it. Now just do one thing, just check the transform data. Just check the transform data. So x underscore train dot head. What is wrong there? Tell me.
I think we need a parenthesis, maybe.
Okay, let's put a parenthesis here. Now just run it. Even I'm getting the error.
Do you have to import NumPy?
We have already import numpy. Okay, just do one thing. Just import the numpy also here. Import numpy as np. Just run this. And once again, just run this. Still I'm getting. Tell me.
Is it because of the space?
No. See,
Okay.
the transform data will always give you in the form of arrays. Okay, and we don't have any function called head in NumPy. Right? We don't have any function head in NumPy. Okay, head is a function of pandas, and your data is now transformed. So if you want to check xtrain, so you have to pass the index value. Let's say I want first 10 rows. Okay, so just put the colon here and just write 10 over here and just confirm it. See, this is your transform data.
Okay.
Clear?
Okay.
Okay. Now what you will do, your data is transformed right now. Now do one thing, just import the model. Okay, and also just do one thing, just check for x underscore test. The testing data set. Okay, and I want first 8 columns. I mean first 8 rows. Okay, see, this is your transform data. Now we have transformed our data it's ready to build a classification model. Okay, so you have to import the model first. So from sklearn dot neighbor, because we are using KNN algorithm, so it's basically a neighbors classification algorithm. So sklearn dot neighbors, GHBORS. Okay, so from sklearn dot neighbors, just import k neighbors. Just write the spelling very carefully. GHBORS. Okay, K nearest neighbor classifier. We are using classifier. And if you are taking the regression type of problem, okay, if you have a regression type of data, then you will use K neighbors regressor. Okay, but now this time I'm solving the problem of classification, so that's why I am using classifier. CLA double SIFIER. Okay. Now just run this. Now we need to make a object of this. So model is equals to, just copy this instead of writing, just copy this, Control C and Control V. Put the parenthesis here and just run this. Actually, do one thing. We have to initialize the value of K, right? So if you guys remember, we have to take the value of K as 5 or 7, right? See, standard value of K is 5 or 7. So in this part, you have to initialize your value. You have to mention the value of K. So how to mention the value? We have a parameter called n neighbors, n number of neighbors. How many neighbors you want? NEIGHBORS is equals to, I'm just taking 5. Okay, so my K value is 5 right now, and just re-execute this code once again. Now train the model. Train the model. So model dot, we have a fit function to train the model, and inside the fit function we have to pass X train, your training data set basically. Okay. X train and Y train. Just run this. Okay, it has successfully done. Okay, your model is trained, right? Now you need to make the predictions. Make the predictions. So for prediction, what you will do, y underscore pred is equals to model dot predict. Now tell me which column do you want to write here?
X is that a X test?
Yes, X test. Perfect. Very good. X underscore test. Why? Because this is your 20%.
Because we are
20%
using this
your,
one to predict the Y one, right?
yes, exactly. Yeah, this is your 20% of the reserved data set, which we have reserved for the testing part, right? This is
No.
your input column. This is your input data. So now, just run this and then just call the ypred. See, this is your predicted output, okay, which the model has predicted. Okay, this is the model predicted values or output. Okay, now do one thing, just match with your actual data set. Okay, now tell me the variable name of actual data set, actual output.
That's Y test.
Yeah, y test. Perfect, you got it. See, the actual output says benign, and the model also predicted benign. Okay, and your model is predicted means malignant, and your actual output was also right? So somewhere it gives you the very good accuracy, Now do one thing, just check for the accuracy part, how much accuracy we got from here. Okay, so accuracy testing or model evaluation. So from sklearn dot matrix import, what I need to import, accuracy score or R2 score? Tell me.
I think accuracy, right? Because accuracy is called R2 is for regression, right?
Yes, R2 score is for regression. Very nice. Accuracy score. Just run this and just print accuracy underscore score, and you will match the column y test and ypred. So almost you got 94% of accuracy, which is very, very excellent.
So Surendra, I have a question. How do you, if you go back and see the number, you choose number 5, right? For class 5.
See, if you uh, See,
Yeah, that
if
one.
you are
So how do
using
we decide? How
n
do we
neighbors,
decide five?
see, already we have discussed in the previous, in the theory part, standard value of k is 5. You can take 5 or you can take 7 also. Okay, but your number should be odd, right? So that's
Okay.
so on the basis of odd number, it will decide the majority part, right?
Okay.
It could be 9, 11, 13, I guess.
No, 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 no. We don't take any more and more number, but it could be 9 also. Okay.
Oh,
Okay. So you can go and check with the 7 also. And okay, just do one thing. We can also check here. See, if we try to put 7 here, just run
Let's
it.
see how it changes.
Again, run it. Okay, and just run again it. And just run this. See again 94.73. What happened?
Very good. So I think it's good. I tried without normalization and the percentage 95.61.
So you got 95.
Yes, without normalization. I just ran the without normalizing it, and accuracy of the model is 95.61.
KNN is very, as I told you, KNN is very smart and very dynamic. If you don't apply the standard scaler, it will also done internally this part. Okay.
Okay.
Okay. So I'm just sharing this file to you guys. Please, please open this and just try to solve this and just keep practicing on that part. I think you have already have this file, right? This
No, go
one.
ahead and share this one for us.
Okay, okay. Just let me share.
Surendra, how do we schedule appointment with you to, because I sent email to solutions and they do respond back to me. So if I want you to clarify something, if I want to have any question outside
Okay.
the class.
So right after the tomorrow's class, we will take a one-to-one. Okay. Tell me.
Okay, okay,
So tell me where, whenever you free, on what time you are.
okay, okay.
Okay. So then I will tell to the support team, then they will arrange.
All right,
yeah,
thank you.
I need a 101 too. I never had it, I think.
Okay.
Yeah,
So
you send
you
email and they
guys,
don't reply.
are you guys asking with the support team or not?
Yeah, I was asking and then he's supposed to reach me out. He didn't reach me out.
Okay. So then again you can call.
Yeah, I text him.
Oh,
He probably
calling is
arranging
better than
tomorrow.
sending email, right?
Okay. Or you can send the email. Yeah, that is again the very good option.
Okay.
Okay. Okay, so basically, right after the tomorrow's class, we will take a one-to-one. Okay, so don't worry about this. I will tell to the support team, but from your side, you have to told them, right?
All
You
right.
will. Okay.
Okay. So from your side, please, at least one time or two time, you can tell them to make a one-to-one. Okay.
Yeah, I will. I send the message. He probably arranging tomorrow, he said.
Yes. Yes. Okay. 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 Okay, guys. So we are going to end this class. Okay. Just keep practicing on this. Okay, and tomorrow we will start a very new algorithm, that is I think SVM, support vector machine. Okay.
Awesome. Thank you so much.
Okay, thank you everyone.
Mm.
All right. Thank you. Good night.
Good night.